Hey, Algebra peeps, Mr. Miller again, and here I'm going to demonstrate our first example of solving quadratic equations by factoring. So let's say we're asked to solve, whoops, let me get a pen going here. Okay, let's do blue. Okay. Let's say we're asked to solve x squared plus 5x plus 4 equals 0. So remember, our first step with solving quadratics was to make sure that we had 0 on one side. And if we didn't have 0 on one side, we'd have to rearrange stuff so we have 0 on one side. Here, we're very lucky. We have 0 on one side. That's beautiful, because we don't have to worry about getting 0 on one side now. Okay, the second step is to factor out the GCF. Let's look at the left-hand side. The left-hand side, we have an x squared, we have a 5, we have a 4. The biggest number that goes into 1, 5, and 4 is 1. We can't factor out any x's because the first two parts of the expression have x in it, but the last thing doesn't. So the GCF of the left-hand side is 1. We don't need to worry about factoring that out because that's not going to change anything. Okay, now what we want to do is factor the left-hand side of our equation. And this is where you want to fall back on the things that I showed you guys yesterday. November 1st. We need two numbers that multiply to what? That multiply to the back end, and that's 4. But those same two numbers have to add to what's in the middle, 5. So let's think for a minute. What two numbers would multiply to 4, but also those same two numbers add to 5? Let's see a different color here. Let's do, let's see, what would be a good color? We'll do red. Okay. What two numbers multiply to 4 but add to 5? If you said 4 and 1, you are gold. You are right on target. Now remember, once you make that choice, these numbers have to be the same for the bottom also. We can't do something crazy like 4 times 1 is 4, and then say something like 3 plus 2 is 5. The numbers have to be the same in both parts of our setup. Okay. Now, how does x break up? How does x squared break up? X squared is going to break up as x and x, because x times x gives us x squared. And in these remaining two spaces, we drop down our lucky lotto numbers, 4 and 1. Plus 4, because it's positive 4, that's why we're doing plus 4, plus 1. And that's it. We factored the left-hand side of our equation. The next step is to set each factor equal to 0. We're going to set this x plus 4 equals to 0 and solve it. And now we're going to set the other factor, x plus 1 equals 0, and solve it. Okay, I can't speak my own talk. I'm really tired. Sorry. What I was trying to say was we set x plus 1 equal to 0, and we're going to solve it. All right, how do we solve x plus 4? To get x by itself, we do what? Subtract 4, right? Subtract 4, and boom! There's one of our solutions. X is negative 4. And our second equation, we need to get x by itself. Subtract 1 from both sides. And shazam, there you have it. There's our other solution. Okay. Sometimes you'll see the solutions written in braces and brace notation. You don't have to do this if you don't want to. I'm just trying to be extra fancy. So our solution set is negative 4, negative 1. Those are the numbers that will make the original equation that we got here true. If you plugged in negative 4, you would get 0 on the left-hand side because you would get negative 4 is 16. Negative 4 squared is 16. 5 times negative 4 is negative 20. And then there's nothing to do with this plus 4 except add it at the end. So we would have negative 16. Positive 16 minus 20. That's negative 4. Negative 4 plus 4 is 0. You can see that's why negative 4 is a solution. Let's do the same thing with negative 1. Negative 1 all squared is positive 1. 5 times negative 1 is negative 5. 1 minus 5 is negative 4. Negative 4 plus 4 is 0. And that's why you can see that these two numbers are solutions. All right, that's it for this example. See you in a little bit for example 2. Adios.